Have you ever pondered the inner workings of machine learning models? How they arrive at conclusions, make predictions, and in some cases even outperform human decision-making? Well, two key concepts that help us understand these are bias and variance. So, what exactly is bias? In the realm of machine learning, bias is the simplifying assumptions made by a model to make the target function easier to approximate. It's the difference between the average prediction of our model and the correct value we are trying to predict. High bias can cause an algorithm to miss relevant relations between features and target outputs, leading to underfitting. Essentially, a high bias model oversimplifies the data, making it lack the flexibility to fit the data accurately. Now, let's switch gears and talk about variance. Variance is the amount by which our estimate of the target function will change if different training data was used. A model with high variance effectively models the random noise in the training data rather than the intended outputs. This overcomplication can lead to overfitting, where the model performs well on the training data but poorly on new unseen data. These two factors, bias and variance, play a significant role in defining the accuracy and precision of a machine learning model. But here's the catch. They have an inverse relationship. As one increases, the other decreases. This relationship is known as the bias-variance trade-off. In the world of machine learning, achieving a balance between bias and variance is crucial. A model with too much bias will oversimplify the data, resulting in poor performance. On the other hand, a model with too much variance will overcomplicate things, leading to an overfit model that performs poorly on new data. The ideal model maintains a balance, minimizing total error. This is where the bias-variance trade-off comes into play. It is the point where we are adding just enough complexity to accurately model the data, but not so much that we begin to model the noise, leading to overfitting. Finding the sweet spot in this trade-off is a fundamental challenge in machine learning. It requires careful model selection and tuning of hyperparameters. The goal is to build a model that is complex enough to capture the underlying patterns in the data, yet simple enough to generalize well to new data. In conclusion, understanding and managing the bias-variance trade-off is a vital aspect of creating effective machine learning models. It's about finding a harmonious balance between simplicity and complexity, between underfitting and overfitting. So, the next time you encounter a machine learning model, remember the crucial roles that bias and variance play in its decision-making process.